Namaskar, myself Gaurav Bhakar. I am presenting this assignment to my course coordinator Professor Sajesh P. Thomas and Professor Somik Siddhanta. We have given 4 tasks. We have to solve the structures, 3 given structures, and their crystal structure, their crystal packing, and the PXRD of those crystals. The first task was to find the point group of the given crystal. There were 3 two-fold axes present in the crystal, and the shape of the crystal was orthorhombic, so the point group should be 2 to 2. And the structure of this crystal was orthorhombic, so the point group must be 2 to 2. And as you can see from these pictures, there were 3 2 to 2 planes. In the next task, we have to solve the 3 given structures. We have given 3 structures. First was HCT, second was and the 2 structures were RMAL and ROPA, RMAL and ROPA. The first structure was HCT molecule. We have to use the OLEX2 software in order to solve this and these 3 structures. For solving the OLEX2 require these following steps. Loading INS file into OLEX2 software, solving the crystal structure as preliminary step using cell access software, assigning atoms to the electron densities in the given screen using different hotkeys. The hotkeys are like control Q for making a structure, automatically making the structure inside the OLEX2, and you can use clean command to clean the excess peaks in the software. Also, you can use mplane command to form the plane on the molecule. It looks quite beautiful with this command. The molecule starts looking very nice and beautiful. So in the next step, performing the refinement operation using cell Excel, you must have these 2 modules, the cell access and cell Excel for the refining. You must have these 2 modules installed in your OLEX2. Wherever you have installed the OLEX2, inside your C drive or somewhere, wherever you have installed it, you have to put these 2 modules inside the folder of those OLEX2 originally present application. Once you have installed these 2 modules, then the refinement of parameters such as anisotropic refinement, you must know these refinement, where the refinement button is, where the solve button is, where the refine button is, where the px density, mass, where you must know all these things in order to refine a much better structure with the minimum RF value. Once minimum value of residual factor are achieved, crystal structure data files are generated. So solving and refining crystal structure in OLEX2 software. Once you have opened the OLEX2, click on the solve button to get the peaks. Once you click on the solve button, you will get something like these brown spheres. These shows the electron density peaks of your heavy atoms like carbon, nitrogen, sulfur, phosphorus, chlorine. You have to assign accordingly to the electron density. Where you see electron density is higher, there must be a bigger atom or more atoms present there, so you have to assign them accordingly. As the first molecule is HCT, hydrochlorothiazide, I know these atoms, which atom is present in the molecule. There were 3 nitrogen, 4 oxygen, 2 sulfur and 1 chlorine atom, and 7 carbon atoms present in the HCT. So when I click on the solve button using the cell access, the software already already know that the structure is like this. So for getting this structure, one must have the cell access and cell excel module inside the OLEX2 software. Next, you have to assign the atoms according to your electron density map. So I have assigned this. It is quite easy when you know the structure of the molecule, but when you don't know the structure of molecule, you must understand the software and the density peaks. Final refined structure with the planes. So this is the final refined structure with the plane. I have added these planes with the M plane command. You have to select the ring and form the plane. The plane could be formed from any atoms, like you can select for any of atoms and any of 4 atoms, and you can make a plane in between them. So I have formed these 6 atoms, plane of 6 atoms inside the, because it is also non-planar. The nitrogen ring is also non-planar, but you can also still make the M plane because the software helps in making the plane whatever the structure is. So solving and defining crystal structure in OLEX2 software. Best possible structure with R1 value of 3.99. So that is how you can get the RF value by solving from the OLEX2 software and refining as well, refining them. You have to keep refining it until you get a green bar everywhere, and you have to anisotropically refine this molecule in order to make the goodness of fit green and minimum peaks. You have to assign them accordingly. If you have assigned the correct atoms, they will automatically become green. So we have 3 molecules, HCT, RMAL and ROPA. So HCT, as I told that I know the structure, so the goodness of fit was even better, and it becomes greener as soon as I have marked the molecules. These atoms inside this molecule are, one ring is non-planar, while the one ring is planar. The final defined HCT molecule with R1 value of 3.99%. Next I have solved the RMAL molecule with R1 value of 3.89%. As I don't know the structure of RMAL, so there might be a fault in the given crystallographic software or my process, inside my process, but I have tried my best. So there were 3 fluorine atoms and 2 nitrogen atoms, 1 sulfur and 5 oxygen atoms. It is still showing orange on the name. As you can see, you have to click on that orange in order to make it greener, but the structure is not showing green. I don't know what was the fault in it, so I have done this only. I have corrected it only to this. Final refined ROPA molecule with R1 value of 3.18. In this there were 3 fluorine, 1 phosphorus and 1 sulfur and 2 nitrogen atoms. So ROPA molecules in sometimes this phosphorus and 4 oxygens showing the hydrogen bond with the nitrogen, and sometimes it is showing that they are not form hydrogen bond with this molecule, but it is present above this whole molecule. It must be forming hydrogen bond with somewhere else, right? Because it cannot stay like this inside a crystal. It must be forming some bonds with some other molecules. So next, crystal packing diagram. So our third task was to form the crystal packing diagram, and the fourth task was to form the PXRD pattern simulation using Vesta. For these two, you have to install Vesta software inside your PC, and then open the Vista software. Once you open the Vista software, click on the file button and open your required structure from the menu. Once you click on the structure, you will automatically get something like this. This is the crystal packing diagram of the HCT molecule. Click on the utility tab, and after that open the option powder diffraction pattern for the graph. You can click on this powder diffraction pattern for this graph that is shown on the bottom left, bottom right. Once you click on the powder diffraction pattern, a graph looking like this appears on the window of your desktop. So this is how you can form crystal packing diagram and PXRD pattern simulation. As it is a simulation, so I would prefer the lab instrument. The PXRD lab, you just have to put the powder there, and it will use Bragg equations and use its ability to get the given PXRD peaks. Crystal packing diagram and PXRD simulation for given molecules. So once you use OLEX, you must know all the commands. There were like 200-300 commands inside this OLEX2. You can use any command to make your structure even better if you know each command very well. I know only some commands so it is new to me, so I have done my best by using these softwares. So these Vista and PXRD simulation, we just have created this crystal packing diagram. This is the HCT crystal packing diagram, and the PXRD simulation looks something like this on the right side. So RMAL molecule, the crystal structure look like this, and the PXRD and the ROPA looks something like this. It was quite a nice task. These 3 and 4th task was done. So the 5th task was to form a report. So this was my report on these 3 molecules. Thank you for listening.